Okay, I just recap it here. I forgot about it. So yeah, so we loaded this network data. What we did here is the objective here is we want to predict whether the attack is whether the packet is attack or not attack, network attack, and malicious, worm, Trojan horse, all these things. So you have that. And so how we started, first thing that we do when we start doing this, our first step is vectorizing the data. This is the first step, vectorizing the data. Okay. Second step is feature selection. Okay. Third step is a neural network model.
Vectorizing means nothing but we are changing the data into a numerical form. Okay.
Right. Okay. So these are the three things that we are doing first. Okay, we have done these two. We are doing this first. Clear?
Okay.
Okay. So now that's objective. So for that, what we do is we need to create a layer with okay, I need to import something. And use this style. Okay. After that, so how many first layer? How many data does first layer have? First layer have 6 data.
780.
Yeah, in this case, you have 6 data, right? From there,
Okay.
you are taking 100. So like first layer has 100 inputs, right? Okay, so
We can increase the nodes from input to dense layers.
this is so how what is this what does it mean now?
In previous examples, we just decrease the number of nodes from input layer to dense layer.
So now since there are six nodes, right? Six data, which is
Okay.
actually it can make it more. Okay. Let me see the data. Okay, now you have 15 layers. Got it, right? It's 15 layers, and you are using software to can calculate the software and output is 6. So what is the total number of total layers? The neural network diagram becomes 6. First layer is say 15 layers, 15 nodes. 15. Next layer is 100.
100.
Right. Next layer is 50. Next layer is 2. Okay. So this is your neural network. Got it, right? Okay. So this is 15. This is 100. This is 50. Where you won't really at this stage. So of course, after this stage, you need to do some configuration also. Okay. So this is your configuration. So after this, what is the next thing that you should be doing? You should be doing to enter the summary of the entire neural network. Okay. Everybody is clear about the numbers here? Right.
Okay.
Okay. So now I want to train the model. Right. So let's train the model. model value dot fit uh, network dx. Network dot. So yeah, so remember that this is one error that network data is one dimension. So generally you have to vectorize it. To vectorize the network data, you have to use there's a function, utility function, which will vectorize it. Yeah, two categories. Okay. So you can use this. Output is currently one column, right?
Okay.
Okay, so you need to be vectorized. Okay, so you have this target.
Convert it into one hot encoder, huh?
Right, absolutely. Okay, network data. If you see target, two vectors, right? So that's what you need. So after that you model value pitch. Okay, network TF, which is the data, and this is the task. Right? You can see here very strange model. Here, okay, I didn't consider epochs and all that. Epochs is going to batch size is equal to 100. Okay. Right. So you can see the accuracy of the model. It's actually, yeah, it's converging now. I think I need to increase the batch size. So maybe 10. 63. It's not really converging very fast. Somehow very slow in terms of conversion. Okay.
How can we decide this batch size, sir, depending on?
See, batch size means if you want convergence to be very fast, right? What you can do is change the batch size. Okay, number of epochs somehow let's say. Since there is very less data, right? I mean, in terms of columns and all that. So see, it is converging, improving, but pretty slowly. Okay.
Okay.
Thank you. 6,4. Right, I mean, this is definitely subject of improving, changing, and all that. But you saw, right? How do you solve just take up any problem? This is more of a encouraging to solve any problem with Google. I mean, what are the things that you should offer? Find cleaning is one part. Okay. And can suppose this is with HGD, right? And this is categorical class entity. So you have this is two class. So in case of two class, so what you can do is you can use this optimizer RMS prop. Is my voice not clear? Is my voice not clear?
Yes, sir. Now it's okay.
Oh, okay. So, so you can see here, this is one of the optimizers that we can try. And loss function can be binary cross entropy rather than categorical. Categorical is when it's multi-class. This is binary class, right? So you can give binary class. Okay. So we saw the first case, then you can change it. Loss binary.
This binary cross entropy only we are having two outputs.
Yeah. In that case, you can use the binary cross.
Sir, epoch means repeating the total data, total training data.
Total training. First time you'll try, the next time you'll try. What is the
Okay.
with respect to that? Okay. And yeah. Okay. So that is how you do it actually. So you might try solving any problem the way you want. Okay, and you can see. Okay, so after trying this, you can increase the number of layers also. Okay, but remember, if you increase, you can see here, number of layer increasing does not mean you are improving accuracy. Number of layer increase means you are, so maybe what you can do is rather than this two more layer, we can simplify this. Right? Okay.
In place of ReLU activation function, we can't change to any other activation function.
Yes, you can change, right? You can change to sigmoid. See here, we very quickly got into 71%, right? Yeah. Did you notice this? So by simplifying the layer, okay, we actually got pretty good accuracy. It's stucking, it's looping around 75 only. It's not improving beyond that. So once this finishes, what we'll try to change from sigmoid ReLU to sigmoid, or sigmoid to ReLU and see the impact. So for a particular problem, you can try solving things like this. Make sense?
For these dense layers, what are the activation functions other than ReLU and dense?
ReLU
and sigmoid.
Sigmoid, tanh. Okay. So these are the popular ones. So this particular case works better with sigmoid than ReLU. Did you notice this?
Yes, sir. Sigmoid is better than ReLU.
ReLU in this particular case.
Okay.
Okay. So that's what actually you have for a problem you have to actually find the steps, do it. See, the sigmoid invariably is giving better than 70. Okay. Of course, you can change different feature selector and all that, and can develop on top. Guys, got everything around it? What the objective is, to pick up any data which you have solved with machine learning and try to solve with neural network. The objective is not performance. The objective is, trying to, experiment it out, see what is happening. Got it, right?
Yes, sir.
Okay. Money, is it clear?
Yeah, one thing it is clear actually.
Okay, okay. Because I solved a very simple problem, but here the thing was just to solve it in neural network, just to be comfortable, how to do things. You take typically did just these three things as mentioned: feature vectorizing, selector if you want to, if you don't want. Like that was the benefit of neural network, right? You don't have to do feature selection. You can live without that as well. Okay. So 70s is the best number that we have, right? Let me try. So this is network data. Network. Okay, you have to convert this network data into NumPy. Maybe let's take 25 pictures. Oh, here this fix it. We want to change something. Right, you get 60, 70, 75. Okay, yeah. So that's the best we can. I mean, we can do more, but it's around 70, 75. Okay, and it's pretty much remaining here. Okay, so later on we'll learn some more techniques to improve the accuracy of this particular cases. Let's proceed further. Okay. Any doubts on neural networks on solving problems? Right. We'll now move to convolutional neural networks with some concepts around it. Okay. Before that, we'll take a 5 minutes break. Okay. After that, we'll discuss convolutional neural networks. Okay. We'll build on top of this. Okay. Neural networks. I will discuss the problems of neural networks, and we'll go to convolution neural network. Okay. Let's take a 5 minutes break. Is my screen visible, guys? Okay, okay. So, okay, I'll be extending it to show some diagram. Hmm. Hmm. Any questions on regular neural network? What are they? How is it done? Some application point of view. Okay, so we'll proceed to neural networks, convoluted one. Okay, so somebody joined. Okay, so let's. Can you see this page on convolution neural network? Do you see Obama's photo here in my screen?
Okay, that's cool. So yeah, I just trying to adjust something. So one thing that, if you talk about images in neural networks, what happens is each pixel is a data, isn't it? Okay, and so the information, each pixel comes as a data. Like if you have a 784 image of size 28 cross 28, each pixel becomes a data. Okay, whereas in what we are looking for is something different here. Okay, so when you talk about images, the CNN has roots in some biological research, and people try to do long-term neural networks and all. Then they wanted to understand how the brain really works. Okay, how brain really works. So they did a lot of experiments on doing that. The fundamental learning that they had is how brain works is basically brain learning in brain happens in layers. Okay, the early layers, like it's very much like neural network. The early layers are responsible for learning simple features, and the later layers are responsible for learning complex features. If you imagine a neural network which is capable of identifying faces, initial layers will learn edges. Deeper layer as we proceed, Like in middle layers, we learn, things making, coming out from those edges and combining, right? There are relatively more complex information. And as you proceed further towards the end of the layer, they are completely learning, okay, I mean, in the middle, towards the end of the layer, you will be learning eyes, nose, the important features of face. Towards the end of it, you will be capable of learning the entire face. Understood how does this learn, feature wise learning proceeds? Okay. Okay, so this this the vanilla deep neural network, right? It has too many weights, and this is the first problem that it faces. Too many weights. Second problem that it faces is overweight, overfitting. Okay, so to understand this better, what happens if you increase the number of layers? Okay, if you increase the number of layers, your the number of model parameters increases. When your model parameter increases to regularize it, so that it does not, or to make it work well, you actually need to train it with lot of data. Got it, right? Okay, so that's what the shortcomings of neural network. So first is, okay, so that's the thing. First is it has too many weights. Next is it gets into overfitting. Now, what is convolution neural network? Convolution neural network takes advantage of the fact that that we are analyzing the images. For example, let's CNN is more than often used for images. Okay, and it tries to build itself on the fact that we are analyzing images. Okay, so this is the first thing. Sensibility constrains the architecture of deep neural so that we drastically reduce the number of parameters in our model. Essentially, in the earlier in the neural network, in the earlier layers, we'll be learning simple features. As we proceed further, learning complex features. Okay, and unlike the previous neural network, here data will be traveling in 3 dimensions across the neural network. One is height, width, and depth. Okay, let's see one by one. Okay, so now, okay, so why we have to understand one thing: the neural network learn features. Right here in the convolution neural network, it actually learns features. Okay, so what it tries to do here is, let me explain it with some concepts. Be a little patient. It is initially a little difficult to understand. Okay, I promise it will be clear by the end of it. Okay, so I don't know why this is not working. Okay, these are some of the diagrams that I had, but I have to show a few more. Okay, wait. Okay. Oh, my screen is not visible.
No, actually, it is struck up. Actually, I
Oh,
just
is
see
it?
the photo of Obama. That's all.
Oh, I have changed. I have shown quite a few things after that. Wait. Okay, no, it's okay. Okay, so yeah, you can probably see the diagram here. Okay, this is our regular neural network, right? We have this input layer, this hidden layer, this output layer, and what you see in the right hand side is a coordinate layer or a convolutional neural network layer. Okay, so let's understand few things. This is a good reference to read, and of course a lot of useful things out here in this repository. Okay, so you can take up the link. But what is happening over here in convolution layer, for say for example, just understand, I'll keep on marking those things. Not so. Okay, just understand, first thing is your input layer. Okay, what are you trying to understand? We are trying to understand coordinates or convolutional neural network. Okay, this is what we're trying to understand, coordinates. Okay, this is also called convolutional mm, mm, neural network. Okay, so so we have one convolutional layer, one pooling layer, and fully connected layer. Okay, so what is this convolutional layer? What is pooling layer and fully connected layer? Let's understand. Huh? Okay, so first is input data. Okay, and we will talking most from the perspective of images only. Okay, the input data. Input layer consists of image. Say the, as you can see here, this image is 32. Okay, cross 32 cross 3. So if you have to represent this image would be like this. Okay, 3, right? 3 for RGB. Okay. Okay. Okay, so this is 4 cross 4 cross 3. Understood, right? This 3 is for RGB. This is how the data is. Okay, so in this case it is 32 cross 32 cross 3. Okay, understood. This is the input layer. This is the input layer. The first layer. Okay, this is the input data. Okay, not input layer. This is the input layer. It consists of 32 cross 32, and we will draw pixel values of the image. Okay, let's go to the next point. Next point is your conv layer. Okay, please understand this. This is the conv layer. Conv layer. Okay, so conv layer will compute the output of neuron that are connected to local regions in input. Each computing a dot product of the weights and a small region that is connected to the input volume. The resultant will be 32 cross 32 cross 12. Okay, don't worry, let me explain it. So what happens is, okay, where is the diagram? So what happens is, say, take this example. Yeah, this is the example, right? Suppose the input has a size 32 cross 32 cross 3. This is the input data. Okay, and okay, and the filter size is 5,5. So what is? I wish I'm turning on the video part. Can you see? Can you guys see me? Yeah. So what happens over here is, okay, you have this image. Okay, this is the entire image. Okay, and what will happen now? Just imagine this is 32. This is 32. Right? This is 32 cross 32, and this is, just imagine this. And the filter is of 5 cross 5. Okay. Oh, I don't know what's the problem here if the screen is freezing. I'll send you a link. So is it freezing for everybody? Because it needs some focus here. Oh, it's okay. Okay, okay. Let me just explain this one concept. Tomorrow I'll actually connect all the things. Okay, just understand this concept of filters. So what happens here is, you have this 32 cross 32 image, and you're making a filter of size. Say, just take an example of, in this case, it is 5 cross 5. So just imagine this is a 5 cross 5 filter. Check another color. So filter I'll be writing with this color. Okay. So say this is the size of the filter. Understood, right? Okay, just imagine this is 5 cross 5. So what will you do here? It will actually, for it, whatever value is here, you try to multiply with this 5 cross 5, and there will be some output. I'll come there. There will be some output. Okay, that thing, and you will continue sliding the filter. Okay, after doing this point, you'll come here. Okay, you'll slide this. So this is the area that you will try to find. Okay, you'll apply, you'll create a filter here, you will map it over there. Okay, this area. So this is what it is, convolutional. A filter will be there, it will move along your x-axis, and it move along. By after finishing that, it will come to the second layer, it will move along this. It will keep sliding this. Okay, by default the slide size is 1. It will keep moving this. And what does it mean by keeping moving and all? There is a cross product. Can you see this? This is the formula. This is the filter data. This is the filtered data. This small data that you see, this is the actual data. Whatever data here and here is like you are multiplying it, the coefficient. The parameter of the input gets multiplied with the filter, and what is the output that you get? You get a feature map. Okay, that's what it is. So then each neuron in the convolutional will have weights in each input. So the total is this. That's what I'm trying to explain. Okay, so what is happening? Your input, right? Your input gets cross product with filter. Okay, the resultant is a feature map. This becomes your input to the next layer. Okay, so what is happening? You have this filter, right? And it actually slides. Okay, and first, if whatever data is there, just see what this is the actual data. Whatever data is there, it is actually doing a cross product there. I'll explain the cross product. It is doing some product, and on doing that, there is some output, and this output is being done for all the data. Okay, so whatever filters, I mean, how many filters you have, you are actually applying that on all the data. Okay, so this is another example. Suppose you have a input volume of 16 cross 16 cross 20. Then using a receptive field is a filter. Then you're using a 3 cross 3 filter. Okay, then what is the output that comes out of this? You're on each data, on multiplying this with each data, you're getting an output of 3 cross 3 cross 20, right? Okay, that's the thing here. Okay, that is your convolutional. Okay, and what is happening? You are actually so after this entire drill, you understood, right? You have the input layer, you have the you have the input layer, which goes to, which cross multiplies with the filter, which creates your feature map. Okay, this feature map is again applied a filter. This again creates a feature map. Finally, what you get is output. Okay, then what happens is the output is compared with the expected this output. This is the predicted output, right? This is compared with actual output. Then the difference kicks in, and then it will back propagate the filter values. Understood, right? The filter values are initially initialized to some values, some random values. Okay, and based on the output coefficients, it will actually modify the filter values. And after the training is over, this is the filters. Okay, whose value is learned. Earlier case, whose value is learned? The weights of the edges. Now using convolution and neural network, your responsibility is of learning weights, or value of the filters. Okay, these filters are nothing but features. As we see, as we break down the entire neural network, we'll see the layers towards the end of the neural network will learn complex features like nose. You can see the diagram over here. It is learning complex features, right? Can you see it here? So this is the initial layer. Okay, it's learning. Okay, and compared to, this is reverse. Okay, so initially, might not be true. Initially, you're learning simple edges and all that. Later on, you're learning complex information. Is it clear, everybody? I mean, we will learn a lot of things, what is padding, what is parameter sharing and all that. But just a heads up here. Is it clear to everybody? Okay, just understand at a high level, this is, okay. This is simple features, this is complex features, you can imagine. Okay, example filters learned by, okay, each of the 96 shown above are of size 11 cross 11 cross 3. Each of one is shared 55. Okay. Okay, so to put it in simple words, what is the thing that you're doing here is you have the input data.
Okay. How many filter layers we are using, sir, here?
You can, filter layers will be as many as you want, like your normal neural network also, right? You can, that is what you play around with. You have to find the best combination of the filter layers. Okay.
Suppose we are using 12 cross 12 filters at the first layer. Going on to the next layer, the filter size may be increased or decreased. It depends.
Yeah. So generally, what people do is, see, if you take conv models, okay, you try to reduce the number of filters. Okay. Okay, you try to, I mean, we'll see that. See, here is a good diagram. See, there is no single way to. So this is your input data. Okay. Understood, right? This is your input data. Is it clear to everybody? Just a example case. This is the input data, and this is your
filter.
Filter, right? Yeah, it's showing all of them, right? This is the filter. So what you're doing a cross product. Did you notice this? The cross product and whatever is the sum, you're putting it over here. Okay, this is what is meant by applying filter. How you are doing? You are actually moving it left to right. Okay, after that, see the movement. Okay, this is one first level of filter. This is next level of filter.
Second filter is also working on the original data. Second filter, we are using the filter W1.
Yeah, please understand, this is not different layers. You have, you have, wait, maybe just that. Okay, okay. So what is this? Width is width and height is 5 cross 5. Why is it 5 cross 5? 7 cross 7. Okay, it is 7 cross 3 and 7 cross 3. And what you have here is, okay. So this is the entire data. This is the first layer, RGB, right? This is second layer. This is third layer. Okay. So similarly, you have filter also of 3 dimension. So first layer is acting here, second layer is acting here, third layer is acting here, right? Okay. And that is creating your one input. I mean, this is the feature vector. So it is creating one data. The second layer is applying on this is the second. There are two filters now. This is first filter. This is second filter. Okay, but these are not across different layers. These are like if you design the neural network. Okay, I'll show the diagram now. Okay. So this is the input volume is of size. K means to K. What are the terms? Right. So you can see here accepts volume size, W, width, height, and D dimension. Okay. It requires 4 hyperparameter number of filters. Exactly. Number of filters. The spatial extent F and the stride S. Amount of zero padding 2. Okay. So if that is the case, what does it mean? The filter dimension is 3 here. That is why you see 1, 2, 3. You can see the last value. And how many number of filters are there? Okay, the number of filters are K, that is 2 here. K, that is 2. That is why you have 2 filter. Got it, right? If I draw the diagram, if I explain, show you the code. Wait a minute. Okay. Okay, so you can see CNN on MNIST. Okay, so okay, so what you have here is see here you have 32, right? 32 filters in one layer. Okay, if I draw the diagram, it will be something like this, right? This is the input layer, whatever is it, and here you have 32 filters. Each filter will be applying on here. Each, it is like this, right? Each filter
So
is
this 32 is K value.
right. This is K value. Okay, in this case K is 3. So in this example K is 32. Got it, right? So there are 32 filters. You're trying to find 32 features, not one feature. Okay, that's what is happening here. You are, what is it that you're doing? You have some different values initialized here. You have some different values initialized here. This guy is trying to find one feature. Okay, this guy is trying to find another feature. Based on, so this has different values initialized. And this is creating a different output. Is it clear?
Yes, sir.
Okay.
Finally, in this layer, we are finding 2 features.
Yeah, 2 filters, right. The output of this is 2 actually.
Filters is nothing but features. Output features.
Yes. In the neural network, it was weights of the edges. Now these are filters. Okay, that's it. So you actually assign one thing and you predict this output volume. This output becomes input to the next layer. Okay, yeah. And one thing, can you see here? This actual data at the outside row is all zeros. Did you notice this?
Bias.
Okay, that is known as padding, because if this is your actual data, the inner 5 column rows, right? This understood, right? This is their actual data, 5 plus 5. Okay, but you need to add here all these zeros so that you can see the movement of the filter, right? Movement of the slider. So you want all the values to be given equal importance. So you actually have to add zeros in the boundaries. Okay, so 5 from 5 cross 5, your output becomes 3 cross 3. Did you notice this? Okay, and how many of these comes, that is dependent on number of filters here, and these become input to the next layer. Mani, is it clear? Jogesh? Not clear, so I'll explain one more time. Bit confusing it is. Just be a little patient with me, and let me explain one more time. Okay, so how to understand this? Okay, so you have this. So what is your input data? I'll keep writing everything. Your input data is 5 cross 5. Okay, then what you did padding. Why you did padding? So the edge also get importance, otherwise the edge will not get importance. Okay, because here by default all the data is touched to 2 times, 3 times. Okay, if you don't add this padding, the edge will be considered lesser time, so the information in the edge will be lost. Okay, so padding. So the purpose is info in edge is not lost. That's the whole drill. Okay, padding info in the edge is not lost. That's the crux here. Okay, so that is why we do padding. Okay, then you have what are filters. Okay, what are filters? These are the weights you're trying to learn so that you extract features. Weights you are trying to learn. Okay, let's see. So what you do is by default you create your neural network as you saw in this previous diagram, right? Okay, a previous code. Like here what you're doing, you're creating a layer with 32 features. What is a feature filter size 3 cross 3? Okay, so you have, and when you initialize this model, these values are by default initialized with some random values. After that, you pass some data, like in this case you're passing this image 5 cross 5. Okay, and one width and one height is increased because of the padding. Okay, we can see this two information is increased because of the padding. Okay, now you can see this filter, this in first time it is randomly initialized, and you can see the cross product happening here. Okay, so let's see this value, how this value came. Sorry, not this value, maybe we'll see, we'll see this value 3. Okay, how does 3 come? So 0 into 0 into 1 plus 0 into 0 plus 0 into 0, anyway 0. 0 into 1, 0, 0, 0, this is 0. So only these two values to be considered. 2 into okay, the only these two values to be considered. So these two values are these two values, right? -1. So 2 into -1 is -1. 2 into -1 -2 is -2, and 2 into 0 is anyway 0. So the -2 should have. Oh, here it is, right? Yeah. So let's calculate this 3. I got confused. Okay, let's calculate this 3. So here you have, oh wait, the order here, the way it is represented here is little different. Let's see how this value. Oh yeah, so you will use this plus this plus this. That's why it will come. Okay, let's see. The output of first guy is, okay, output of doing this guy here is -2. Okay, understood why? Yeah. So what you're doing, you are actually, I'm drawing it here. You are taking this. Okay, you are you're multiplying with this, you're taking this, multiplying with this, you're taking this, you're multiplying with this, and you're summing it all up. Then you're getting this value. Okay, let's see. So here we saw it was 2 into -1, that is -2. Here, if you try to multiply it over here, okay, only these two values are there. Okay, 2, that's it. Okay, so +2. The last thing that you saw here, only these three values, 2 more. +2. Okay, and you have a bias here 1. Okay, so that makes it 3. Okay, that makes it 3. Similarly, just see this guy, next guy. Okay, next guy, maybe not next guy. I can see this guy -6 here. So this guy, this into this, right? So you can see all of these are, it's becomes very complex. But anyway, this is how the maths happens. Is it clear? So this is like, cross product of this plus this plus this. Okay, and plus bias. That's what it happens. Is it clear to everybody? How we got these values over here? Sojanya, Mani, Jogesh, is it clear? We can do this.
Yes, sir.
Just so if you want to do this guy with this guy, right? So only these two values are anyway there. Rest of them are not there. So if you do 2 into 2 is 4, 2 5 is 10 minus 10, right, is equal to -6. First guy. So this guy and this guy. So you have only these 4 values. Hey, how did this 10 come? Okay, 2 into,
Sir, it was it cross values.
yeah. So it is. I think I saw something else. It's little. 2,
First vertical will multiply with this horizontal thing, not with vertical thing. No, you are multiplying, no, sir. First 3 bits with the 3 bits. You are taking first vertical thing.
No.
First,
All of them. Just that it is 0, so I'm not using them. All of them cross product, dot product actually. Each of them, dot product, not cross.
okay.
Okay, so like 2 and 2 is there. I will.
Sir, but when I did this cross product only, it worked out the 3 value.
Cross. So you would have done this, right? 0,
Yes,
1. Sorry. So here 2 into 2. So only one value. So out you are doing cross product of this guy and this guy. It is -2. That's what you did, right?
what, sir? Again, repeat it.
Okay. Cross product.
For
is
0.
Then
Yes, cross product of those 2 values will give 0, and for 1 it will give 2, and for 2 it will give 1. So adding 3 of them, 0 plus 1, 2 plus 1, it will giving 3.
this, right? Minus.
Yes.
For if you do cross product of this guy and this guy, the output is -2. If
No, 0.
0. -2.
0.
Because you have these 2 here. You have
No, you are doing the dot product. It won't work.
No, it is dot product actually.
Okay. But when I did the cross product only, it came the value of 3.
No. And you have bias here. Okay, so this is like okay, this into this. These are your data, and this is your weights. Okay, the x in
Okay.
you have to multiply, and then you have to, this is similar, right? This is your w vector cross x vector plus b. That's what you're doing here.
Okay.
Okay, so okay, let me, you know, if you have this guy and this guy, okay, and the bias is 0, so I should get my number minus 6. I should get my number minus 6. Okay, so how this should happen? 2 and 2 is here, right? So here minus 2 minus 2. Okay, so minus 2 is minus 2 is equal to minus 4. Okay, then coming here you have 2 2 1 2 1. Okay, that is 2 1 is 2. This guy is anyway 0. 2 minus 1 is minus 2. 1 minus 1 is minus 1 is equal to minus 1. Third guy has 2 columns, and in this only this data is there. So 2 minus 2 minus 1. So this is minus 1. So this is minus 6, and plus 0 plus 0, that is minus 6. Is it minus 6 here? Yeah. Got it, right, everybody? Saujanya, Tarun, Jogesh, is it clear?
Yes.
Okay, so this is like dot product of this is that you're trying to w you know, the weight vector into x vector plus your bias, and this entire thing is coming up as this. Okay, so that is what you're doing. This is known as convolution. Convolution means you're applying something, and you're moving through actually. Okay, I mean you have a, you know, you have a slider. It's like a slider. It's going through all of them. Got it, right? And you, so by default all these values, so the objective is by default these values are randomly initialized, bias, and all these values based on the output, like we've seen in neural networks. It will you know, change the weights of change the filter values so that you start predicting something more accurately. Is it clear?
Yes. Yes.
Okay, this is known as filter, and there are a few more things here. There is one term, stride. Okay, by default it is 1. What is 1? You can see the movement here. It is 1 step at a time. Okay, that is 1. If you make stride 2, it will be 2 step at a time. Okay, and let's see the maths. Okay, this is, everybody understood what is striding? Striding is the jump size here. You can see the jump by default it is 1. Okay, it is it is 2 here. Here stride is 2. See the jumps here. See first. Is it clear? Stride is 2 here.
Yes.
Okay, now let's understand how is this sizes coming this way. Okay, first initially what is your image data? Image data is 5 cross 5 cross 3. You did padding, so it became 7 cross 7 cross 3, right? That is what is this case, with all boundaries 0. All this you know, at boundary data is 0. Okay, then you have 7 cross 7 cross 3. Then you have 2 filters. Okay, 2 filters, W0 and W1. What is the dimension of this 3 filter? It is 3 cross 3. This is one. This is the filters. Okay, this is RGB, so it is this, and you have 2 filters. Okay, so one is W0, other is W1. Okay, now when you have a when you have W0, W1, okay, so these are the weights that you have to learn. Okay. Sorry, these are the filters. Okay. So we have now configured two filters. You can see two filters. So what will be the output? One filter applied to this entire thing. It will be 3 cross 3 into number of filters. Right? That's the output size. Why it is 3 cross 3? Because from 5 cross 5, the image will be, because of 2 striding, the image will be reduced to 3 cross 3. Right? It is coming from there. Right? Acha, guys, tell me, if you move this matrix by rather than 2 by 1 value, stride 1, what will happen? This is it, because this is 3 cross 3 because of stride is equal to 2. If you make stride 1, okay, what will happen? If you make stride 1, the output size will be how much? 4 cross 4. Is it clear? So in that case, number of output will be 4 cross 4. Is it clear, everybody? I'll do this one more time. I understand in one shot it is never clear. Okay, but
Yes, sir.
hmm?
Stride is okay.
Yeah, stride. If you reduce the stride, so okay, so you can see here. You can see the dot product weightage. Okay, so maybe you know. Okay, then after that we learn about pooling layer. Okay, what is pooling layer and all that. Yeah. But I would want everybody to revise this. I'll show the recordings. Maybe I'll upload it. Okay, I'm just checking if it is last week's. Looking for Mitesh. Oh. Okay, this is deep learning session 1. Oh, I think it didn't convert. Let me convert. Okay, I'll upload the link and I'll mail it to everybody. Okay, just read a little bit about convolutions. We'll spend a lot of time in convolution layer. What are the root things here? What are the things to be understood? Okay, finish some neural network coding today and try to understand what are various concepts that we discussed: striding, padding, then filters. Okay, try to correlate. What will happen. I'll just put this entire story in one bucket. So what is this filters? These filters are like complex features. Okay, and unlike what we learned in our neural networks was weights of each pixel or derived pixel. That's what we learned. Weights of each pixel or derived pixel. That's what we learned. Okay, and in convolution, this is a neural network. In CNN, we learn weights of in CNN, we learn weights of features or filters. Features or filters. Right. So what is the thing here? You are not doing the learning based on pixel value, right? You are waiting for features, and the possibility of features use it quite high. Okay, that means if you talk about some eyes, I mean eye. Okay, so we have two eyes, so the same feature will be available for both. Got it, right? You actually are trying to find same feature across the entire image. So this is what is known as feature, parameter reusing. You might hear this term in convolution neural network, parameter reusing parameters and all. This is what it means. Okay, so it will be clear. Just be a little patient, and we'll try to connect all the things here. Okay. Okay, guys, go through this. We'll discuss a lot of details tomorrow. Okay, thank you.